Hey Bobcats, this is Mr. Peterson here. Today we're going to talk about transforming quadratic functions. Alright, a couple things for your notes here. We have the standard form of a quadratic, which is ax squared plus bx plus c. We should know that. But then we also have vertex form of quadratics, which is new to us today. It's f of x is equal to a times the quantity of x minus h squared plus k, where h is our x coordinate of our vertex and k is our y coordinate of our vertex. Alright, so in your notes page you also have this table. Take a second, pause the video, fill in some of the blanks. Okay, let's look at two examples. Let's look at two quick examples. Alright, the first one, you can see here I've already pulled up the parent function x squared, and then here's another one for you, the quantity of x plus 3 squared plus 1. Now you might be thinking about that, Mr. Peterson. Okay, I can see why the plus 1, it moved 1 up, but why the plus 3? Why the plus 3? And to answer that question adequately, we have to think back to vertex form of a parabola. Remember, we want it to, the number we want our x coordinate to be is -3. So when I do x minus a -3, what does that become? Well, that actually becomes x plus 3. Hence, when you look at our parabola, that's where we wind up with our vertex. Alright, let's look at another example. Delete this one off of here. The quantity of x minus 2, close parentheses, squared, minus 1. Now, before I hit enter here, I want you to think, what is that going to do? Oh, I need to fix that really quick. That's x minus 2. Okay, think, what is that going to do? Alright, there we go. You can see that it moved the parent function 2 units to the right and 1 unit down. Okay, so here's our -1 and then minus 2. And you can tell our x coordinate is at positive 2. So remember, in our vertex form, it's x minus some number, positive 2 in this case. Alright, so why don't you try this one and try this one. Alright, now in your notes you also have this table. Go ahead and take a second, pause the video, fill in the blanks in your table. Alright, good. Let's look at a couple more examples before we end this up. We have -4, wait, the minus sign, -4x squared. Alright, now before I hit enter here, I want you to think, what is that going to do? What is that going to do? Alright, so we have -4x squared. I'm going to pull the equation back up here so we can look at and analyze it. Alright, the x squared, or the x, is getting multiplied by a -4. It's getting multiplied by a -4. So when you look at your rules here, when we multiply the x squared by something, it winds up doing a vertical stretch or a compression. And in this case, we multiplied by the number -4, which has an absolute value greater than 1. So this is going to result in a vertical stretch. And then it was negative, which means it's going to open down. So what we have here is a vertical stretch by a factor of 4. A vertical stretch by a factor of 4. Alright, let's look at another one. Alright, this time we're going to put the parentheses around the x. Just the x this time, that's important. And we're going to multiply it by 1/2. Alright, now before I hit enter here, I want you to think, what is that going to do? What is that going to do? Okay. Remember, here is our parent function, the blue one. The red one is the one we just did, 1/2 x, all of that squared. Alright, well, that resulted in a horizontal stretch. A horizontal stretch. If we look back at our table from the previous page, we're multiplying the x only the x, not the x squared. We're multiplying the x by a fractional number in this case. And since the absolute value of it is between 0 and 1, this is going to wind up being a horizontal stretch. A horizontal stretch. All right, so why don't you guys try, oh, wrong thing. Why don't you try this one and try this one? And we are done. See you in class today.